Today is lesson 1. So what we are going to learn today is internetworking, the basics. So in this lesson, we are going to look at networking devices. So what are the networking devices that we are going to look at? We'll look at switch, we'll look at hub, and we'll look at routers. So let's call this one lesson 1 part 1. All right, because we can further with part 2 where we have firewall, access point, wireless controller, and so on. But for this particular lesson, let's just cover these 3 network devices. That will also help to avoid the lengthy videos, because at times when you are doing the video and then it's long, other people get tired in watching a long video. But before we move on these 3 devices, we have to define what is a network. Okay, this is very basic, okay, because you can find a definition everywhere. When you Google it, you'll get a definition. So I'm not really going to spend much time on defining this one, but to make everything short, I can just tell you that a network is just interconnection of devices, of network devices, in order to share information. That's what I can tell you, like something very basic. But if you want, long definition, you can just Google and then you get what you are looking for. Okay, so to start with, let's start with the app. Okay, let's start with app. So what is a hub? A hub is a network device. Is a network device which operates on layer 1 of the OSI model. We'll get to this one. For those who have no idea about the OSI model, we'll get to there, and then you understand the reason why hub is in layer 1. How does this network device operate? This network device operates in a broadcast format. What do I mean by it operates in a broadcast format? If we have this hub over here, and then we have user 1, we have user 2, and we have user 3. Okay, and we have, let's say, user 4 over here. If user 4 want to send a message which is destined to user 1, what will happen is that this message will now be sent across these 3 users. So at the end of the day, there is no what we call confidentiality. There's no secrets. You cannot just send a message which is destined to user 1. What you are supposed to send, or what is supposed to be delivered to user 1, will be broadcasted to the user 2 and then user 3. So if you have a device which cannot help you to send confidential message or secret message, meaning this device is useless. There is no need of using a device which does not guarantee privacy in between 2 devices or a group of people. So that's what you have to keep for the hub as a network device. And also, a hub has what we call collision domain and broadcast domain. With the hub, we have one collision domain and one broadcast domain. This same hub, among all the ports that it has, it shares what bandwidth. So it's not something you can rely on. So this particular device, the interfaces, they all share the same bandwidth. That's how come the message is destined to one device is now going to be sent across the other devices. So what you have to keep in summary is that a hub is a layer 1 network device on the OSI model. It has one collision domain and one broadcast domain. That's how come the message is being broadcasted, across the multiple devices. And the bandwidth over here, it is a shared bandwidth. I hope you have gotten this one right. If you have any question, kindly let me know in the comment section. I'll be glad to read your question and if possible, leave an answer. We are done with this network device. We move on to the second network device, which is a switch. And then, okay, there's something I did not mention over here, okay, which is a MAC address. MAC address. Why is it that a hub does not deliver the message to the specific destination? Because there's no reference, there's no address. Let me take an example. Okay, I enter a particular room where I have a lot of students. I'm just interested in one student. If I don't know the person's name, how am I going to index the person? I don't think there's any way for me to designate the person I'm looking for unless I have reference or information related to the person. The same thing happens over here. So basically, with the app, when you walk into the room and you've seen people, you want to talk to one particular person or one student. What happens is that instead of you addressing your voice to that specific person, we're now going to voice up to everybody. So what was supposed to be heard by one person, everybody's going to hear what you are supposed to say. The same thing with the hub. So that's why it's not considered as a better network device to use because it's not going to guarantee a secret. Move on to the second device, which is a switch. The switch is more intelligent than the hub. Why am I saying a switch is more intelligent than the hub? Because this switch delivers the information based on the address. And which address is a MAC address? If I may ask, what is a MAC address? This is also a definition you can, find elsewhere, Google, Wikipedia, and so on. But I can just give it to you. A MAC address is basically a physical address of a device. So when you take your iPad, when you take your mobile phone, let's say your iPhone, when you take your Samsung, when you take your television, there are a lot of countless of devices with a MAC address. So this MAC address is being given by a vendor. And when you see two devices coming from the same vendor, you can easily recognize them by looking at the MAC address, because when you look at the MAC address, which is 48 bits long, okay, the first 24 bits are unique for the devices coming from the same vendor. For instance, if you take HP, for instance, when you take two laptops, let's say PC1 and PC2. These two laptops are what? Are HP laptops. When you check their MAC addresses, you realize that the first 24 bits are what? Are identical. The reason is that they are all coming from the same vendor. Very important to know. Yeah, so coming back to what I was saying, the switch delivers the message based on the address, which is the MAC address. And I've explained what is a MAC address, which is a physical address of a device. And one thing you have to also understand is how the switch is able to manage the addresses, which are the MAC addresses, because of something we called MAC address table. Is also called a CAM table, content addressable memory. This table helps the switch to keep record of MAC addresses of devices and the ports. So if I have if I have a switch as a device, meaning this switch has a memory, which is a table. On this column, it will have what? A MAC address, and on this column, it will have what? A port. So we have something like this. Meaning here we'll have something maybe AAA as a MAC address, and here it will be 01. Let's say fast Ethernet 01. Here we have maybe DDD, and here we have fast 02. Meaning what? When you see something like this, meaning there's a PC with a MAC address AAA connected to the interface fast01. On this side, there's also a PC with a MAC address DDD connected to the port F02. One more detail to keep is that this CAM table or MAC address table keeps this information for a short period of time. So if you are watching this video, one question I'm going to ask, which you have to answer in the comments, is that how long does a switch keep the MAC address table in the MAC? How long does the switch keep the MAC address inside the MAC address table? You have to answer this question in a comment below. Thanks. Let's proceed. Yeah, so with the switch, we said earlier on, the hub shares what? Bandwidth. But with the switch, it's not the same thing. We also said earlier on, the hub has what? One collision domain and one broadcast domain. If you are new into networking, you have to understand the concept of collision domain and broadcast domain, because those days, those who were writing the Cisco session exams were having questions whereby they would draw a diagram and ask a learner or a student to identify the number of collisions domain and number of broadcast domain, and they will give options, right? So you study the diagram and identify the collision domains and broadcast domain before you can answer the question. It's something very important which you have to know as a computer science student or a tech enthusiast. With a switch, we have one broadcast domain. And then some of you may be asking, what about the collisions domain? Here on the switch, each interface of the switch represents a collision domain. I'm saying each interface of the switch represents a collision domain, meaning what? If this is to be a switch with 3 ports, this one is one collision domain, this one is one collision domain, this one is one collision domain, which was different with the hub. And if, let's assume this is F01, F02, F03. So if F01 sent a message to F02, F03 is not going to be aware of what is going on. So the communication is between two people. If F03 decide to send a message to F01, F02 is not going to be aware of what is happening because the communication is between two people or two users. This is what makes the switch special compared to the hub, because with the hub, the message will just be flooded across all the interfaces. But with the switch, the message is delivered to the specific destination. If I ask someone, go and call me B, the person will call B is not going to call A, B, C, D up to Z. No, it's going to call the specific person. And this one is because of the MAC address of the device. I hope everything is clear. So if in a scenario whereby they ask you to, okay, let me give you one scenario over here. Okay, I can clean nothing up there. If I have a switch like this, and I have another switch here, and this is one interface, this is another interface, and here I have 3. Okay, I say this is connected to this, and I have devices connected. And then if in this scenario, okay, if they ask you how many collisions domain do we have, how many broadcast domain do we have? So simple. Remember, I said that each interface of the switch represents a collision domain, and a switch has one broadcast domain. So what I'm going to do is this. This one is a broadcast domain because they are connected, okay? And these ones are collision domains, meaning what? I'll have 1, 2, 3, 4, 5, 6, 7, 8 collision domain for this entire lab. Very necessary to know about all these ones. So what we have covered on this lesson, we have discussed about hub, we have discussed about switch, and also talked about collision domain and broadcast domain. I hope everything has been clear. Thanks for watching. Subscribe to encourage, share the video to the maximum so that we can grow the community, and also Let me know in the comment section if the video has been informative. Thanks for watching. I will see you in the next video.